Then the next chemical property or reaction is with reaction with Heinsberg reagent. Now it will be the earlier one also the distinguished test between primary with from secondary and tertiary, right? And HEINS. Okay, this is HEINS Heinsberg reagent. It is also used to distinguish between primary, secondary, and tertiary amines, and it is chemically known as benzene sulfonyl chloride. With the formula you will write down this way: benzene sulfonyl chloride. Right? We will just first get it reacted with the primary amine. So this is benzene sulfonyl chloride or Heinsberg reagent. You can simply write it as SO2Cl also plus RNH2. This is the primary amine. So here this Cl will get removed to that. It's minus HCl. We will get here S double bond O. This is double bond O. This is NHR. Now since the sulfonyl group is bonded to the nitrogen atom which is having a hydrogen, so it will show a acidic nature. Now it is acting as a acid or acidic behavior it shows. So when it is treated with a KOH or an alkali, right, so it will form a salt, right, and hence it is soluble in alkali. Due to formation of salt, it will be soluble in. So you can easily show the formation of the salt, right? Here it will be there S double bond O, and this is going to be NRK. Right. Now this compound which has been formed is known as N, alkyl benzene sulfonamide. Right? And along with it, water will be formed. But student, when we are taking the secondary amine, so there SO2, and this is a secondary amine. Let's take example of it. R2N. This is secondary amine. So you will see that the reaction is taking place. So we will get here this compound which is known as N, N dialkyl benzene sulfonamide. Now, since you see that it doesn't contain the replaceable hydrogen or the sulfonyl group which is present here, doesn't have a hydrogen atom near to it, so it is not going to show the acidic behavior. So when it is dissolved in alkali, it is insoluble. Right? So here it is getting distinguished from the primary amine. Now student, if we take our tertiary amine here, so a tertiary amine, this is a tertiary amine R3N. So here you can see that the amine doesn't have any hydrogen atom with it, so that it can react with HCl. So here there will be no reaction. There will be no reaction. So Heinsberg reagent is used to distinguish between the primary, secondary, and tertiary. Right? Now, students, we will next see the reaction for the. We will have the reaction, the carbylamine reaction. This is the carbylamine reaction. Here, student, it is again for the primary amine. Only primary amine is it. Right? So we are writing here RNH2 plus chloroform CaCl3 plus alcoholic KOH. Right here, the primary amine will be converted into students isocyanide, right? So here, if you want to show it's in this way, it will form RNC, that is the alkyl isocyanide formed, which has got very unpleasant or offensive or foul smell. Right, along with that, you can write down KCl water. Right, this test again will be given by the primary amines, aliphatic amine, and aniline will also give it. Right, so an aniline, which is again come in the primary amine also. So it will show this test, that is the carbolamine test. Right, and this reaction heating also requires the carbolamine test. Okay, students. Now, students, the amines, aromatic amines, they will show the coupling reaction also. That is, we have benzene diazonium chloride, right? Its reaction with the aniline. So here, this is going to form, right? This is there. This is an orange color dye which is formed para amino benzene, right? So the aromatic amines will undergo, students, the coupling reaction also, right? Here it will form the para amino benzene, a colored compound, right? And definitely the temperature here will be kept low. It is 0 to 5 degrees Celsius. Now, students, we are going to discuss the electrophilic substitution reaction that is shown by the aniline, right? So next is the electrophilic substitution reaction. So aniline, you know here the NH2 group that is present here, it is it increases the electron density at ortho and para position. Right, so when you will draw the resonating structure, you will get the electron density high at the ortho and the para position. So when aniline undergoes the electrophilic substitution, it would be bromine water, right? So it is substitution is of such a greater magnitude that we get the tri-substituted product, that is 2,4,6 tri-bromo aniline, right? So if you want to get the ortho and para products, students, we have to protect the nitrogen atom, right, and its electron pair. So for that, we are just going to protect the amino group. So for that, how we are going to do it? Protection of NH2 group. So we will get it reacted with acetic anhydride. This is NH2. We will get it reacted with acetic anhydride. So you will see here it is NH. This is COCH3. Now, students, the lone pair on the nitrogen atom will be under the influence of this carbonyl group also. Right? So next, whatever we want to do, whichever substitution we want to do, either we want to do the bromination, or we want to do the nitration or sulfonation, we will follow them next. Here we will add, in nitration we will add a concentrated nitric acid and H2SO4. If sulfonation, we will add sulfuric acid here in this at this step. Right? So when the bromination will take place, is NHCOCH3. So we will get the product at the ortho and the para position. It is this. Now we have to remove this. For that, we will just carry out the hydrolysis, whether it be an acidic medium or the basic. So this is the hydrolysis which will be carried out. We will get ortho para substituted product. So it is orthobromamine and this is para-bromoamine. Right? Along with that, student, we will get acetic acid because this CH3CO is going to get removed. Right? So whenever the electrophilic substitution will be carried for aniline, the first and the foremost step is to protect the amino group, right, so that we don't get a tri-substituted product. And to get the ortho and para protection will be followed by the step which we want to do. If we want to have the halogenation, we will use the halogen, get it reacted with it, and for the nitration, nitrating mixture, and for sulfonation, we will use sulfuric acid. Okay, so here we are going to end this unit. Right, students? So get this reaction noted down in your notebook.